All right. So remember, we have discussed about the second order differential equation for homogeneous, okay, and then for non-homogeneous. All right, what are the difference between homogeneous and non-homogeneous? Anyone? Okay, thank you. Homogeneous, fx equals to 0. Non-homogeneous, your function, your right-hand side function is in terms of function of x. Okay, where there are cases that we need to consider, for which there are case 1, which is polynomial, right? Case 2 is exponential. Case 3 is sine or cosine, and case 4 is sum of the above cases. All right. So now we have here case number 3, sine or cosine. Okay. So we have the differential equation here. Let's take a look at the example. We have the differential equation is given. Okay. And it is in terms of sine, the right-hand side function in terms of sine. Okay, this is your fx. And this is another types of non-homogeneous, which is focusing on case 3 for method of undetermined coefficient. Okay, so how can we solve this? Again, we are using the same step. All right, what is our first step?
Find YH.
Okay, so again, of course, you need to find your YH, right? By converting this differential equation to characteristic equation of m squared plus m minus 2 equals to 0. Okay, and here you will have m equals to what? Okay, m equals to minus 2 and 1. What are the types of roots here? Okay, YH equals to, right? So this is real and distinct, then your YH equals to, just say it. Right. Okay, thank you, Firdaus. Okay, thank you, Join Yap. And the YH is AE X plus AE minus 2X plus BE X. Right? Following AE to the power of M1X plus BE to the power of M2X. So this is your YH. Okay, now, in order to find YP, okay, first you need to check your Fx. When Fx equals to sine X, then when Fx equals to sine or cos beta X, then your YP should be X to the power of R, C sine beta X. Your beta here is 1, so C sine X plus D cos X. Okay, whatever your function here, either it is sine or cosine, your YP should consist both sine and cosine there. Right? So this is the general form of trigonometric function, which consists of sine and cosine. So that it will ease us for it will ease us to use any trigonometric identity later on. Okay, so now this is quite identical which with the exponential. Okay, if your function is CEMX, then your YP should be XRGEMX. The M value here must follow with the M value in the function. So same with this one. the beta value here should follow the beta value in the function where it is sine 1x. So beta is 1, so sine x. All right. So now you have your YP. And then what's next? What should we consider with this YP? Same process. Okay, you need to check with the value of R. So when R equals to 0, then YPX equals to C sine X plus D cos X. So now you have to check, is there any similar term with YH? So no similar term. Then you just can proceed with, okay, with the next step by matching the differential equation with the YP there. So your YP equals to C sin X plus D cos X. Then you need to have Y prime and Y double prime. What is your YP prime here? All right, anyone? What is your YP prime and your YP double prime there? Okay, so this one is minus C sin X plus D. Itu balik. C cos X minus D sin X. Okay, and then this one is minus C sin X minus D cos X. Okay, now substitute to the differential equation. So you have here what? Just substitute everything here. Okay, and then you simplify. All right, then you can find the value of C and D here. So for those with sine, compare with sine. Okay, then this one is what? Minus 3C minus D equals to 1. And then another one is C minus 3D equals to 0. Then you can find what is your C and D. Okay, what is your C and D? All right, C equals to minus 3 over 10. D equals to minus 1 over 10. So your YP should be C sin X minus D cos X. Okay, then your final solution, just combine both YH and yp, which is okay, clear now. Now it getting easier because you have understand the step, right? Just different function. Anyone has question? All right. Okay, try it first. I give you around 2 minutes to understand, and you have problem, you can ask. Okay? No question, no problem? All right. So let's just proceed. Okay. Let's proceed with the next case, which is the sums of cases 1, 2, and 3. Okay, we have polynomial. In case 1, we have polynomial. Case 2, we have exponential. Case 3, we have sine or cosine. Now, in case 4, it is a sums of cases 1 or 2 or 3, either 1 plus 2 or 2 plus 3 or 1 plus 3 or 1 plus 2 plus 3. Okay, so if your function in the right hand side is equals to a combination of f1, f2, f3 here, which comes from case 1, case 2, or case 3, then your yp is yp1 plus yp2 plus yp3 up until ypn. So the solution becomes yh plus yp1 plus yp2 and so on. So still, we are using the same process, but we have to find YH, of course, okay? And then YP1, YP2, and so on. Okay, and then same process, choose the smallest R from 0 to N, okay, in order to make sure there is no similar term corresponding with YH. All right, so let's take a look at this. Okay, now we have Y double prime minus Y prime minus 2Y equals to exponent minus X plus X. So this is a combination of which cases? Okay, which cases is a combination of this one, exponent minus X plus X? All right, so it is a combination of polynomial and exponent. Okay, so of course, in our first step, you need to find YH. Same process. So your YH is what? YH is converting this. Okay, and then your M equals to, I think it is the same function with the previous example. So your YH is AE, the X plus BE minus X. Okay, and then in order to find YP, okay, now it is a combination of polynomial and exponential, which is come from case 1 and case 2. So your YP should be YP1 plus YP2, where YP1 equals to what? Sorry. Okay. So let's start again. In order to find YP, you have to take a look at your function. Okay, your function fx is exponent minus x plus x, where this is a combination of f1 and f2. So this is your f1x, this is your f2x. Okay, now, and in order to find yp, you have to have yp1 and yp2, where yp1 should follow f1x and yp2 should follow f2x. So now let's take a look. Okay, f1x equals to exponent minus x. Then your yp1 equals to x to the power of r c exponent minus x. Okay, then same process. You have to choose when r equals to 0, yp1 equals to c exponent minus x. Is there any similar term with yh? This is your yh. Yes. Then we cannot choose this. Then check again when r equals to 1. So when r equals to 1, your yp1 equals to xc exponent minus x. Is there any similar term? No. Then proceed. So this is your yp1. Then proceed with what? Proceed with, by checking the differential function, we have y double prime minus y prime minus 2y, okay, equals to f1 only, because we are considering f1 only. So we have to have this y prime and y double prime, but you just compare with f1. Okay, same process with the previous one. You need to have your yp prime, yp double prime, find the constant c, then that is your yp1. And then again, find yp2. Okay, so now let's find yp2. If your f2 equals to x, then your yp2 equals to x to the power of r. This is only n equals to 1, so c1x plus c0. Then again, check. When r equals to 0, yp equals to c1x plus c0. No similar term, then just proceed with this. Okay? Just proceed with this, matching with the differential equation equals to x. Okay? So solving this, you have to have your yp prime, yp double prime. Okay? And identify the value of constant there in order to find yp1 and yp2. Okay, solve this to get your yp1 and solve this to get your yp2. Okay, try it. Same process, but just twice calculation here, right? Okay, try it. Yes, no similar term for YP1 r equals to 1. Okay, please proceed this one. Try it. If you have problem, you can ask. All right, got it? Alright. Got it or not? You know how to do this? Anyone has problem? Your YP1 should equals to minus 1 over 3 xe minus x. YP2 equals to 1 over 4 minus 1 over 2x. So total your yx should be yh minus 1 over 3xe minus x plus 1 over 4 minus 1 over 2x. Right? Is it same with me?
Yes, doctor.
Okay. So if it is not same, kindly check your answer again, right? Where is your mistake? And this is how we do it. Where, when the function is a combination of any case, either case 1 or case 2 or case 3, okay? Then you should do one by one in order to find YP1 and YP2 and combine both as total YP. And again, you have to combine YP and YH to get YX. This is how you did. Okay? And is there any question?
Okay.
All right, good. Okay, let's try to solve the exercise here. All right, we have 3 questions here. Try to solve this. Let me give you the answer so that you can compare.